Hello everyone, I welcome you all to Startup Academy, your online gateway to success in ISS exam. This academy is exclusively for ISS exam. We have been covering the topic sampling techniques, in which we have covered simple random sampling with replacement, without replacement, stratified random sampling. We have done two PYQs on stratified random sampling as well. And we had started doing systematic random sampling, and today is the second lecture on systematic random sampling. We have the basic structure and the definition, everything of systematic random sampling. Today we will be doing estimation of variance of y bar systematic and estimation of y bar systematic, both of them. So this will be the thumbnail of the video, systematic random sampling part 2, so that you can easily go at it. So let us begin. Systematic sampling. So in systematic sampling, Yij is the unit at I plus j minus 1 into k serial number in the population. This unit is Yij is I plus j minus 1 into kth unit in the population, which is taken from the sample. So we had done the outline of the systematic sampling. From that chart you can correlate this, where this will come. And let us where I goes from 1 to k and j goes from 1 to small n, and I is always less than equal to k. This is it. Now let us consider the ith column is our sample. Let us take ith column as our sample. So if we take ith column as our sample mean would be, we will denote sample mean as y bar systematic, or we can also write it as y bar I dot. Dot means j is changing and I is constant. So what are the notations of j? 1 upon n summation j goes from 1 to n y I j, where I goes from 1 to k and j goes from 1 to small m. This will be the formula for systematic sample mean y bar sy, or we can also denote it as y bar I dot. Now population mean. Population mean can be written as y cap, which is nothing but 1 upon n into 1 upon k summation I goes from 1 to n some sorry summation I goes from 1 to k and summation j goes from 1 to n yij. Now here we can take 1 upon n summation I goes from 1 to k, 1 upon k summation j goes from 1 to n yij. This will be n and j will be exchanged. Here it will be k and here it will be n. If we consider this, then we are left with 1 upon k summation I goes from 1 to k y bar I dot. This is nothing but sample mean as we did here the formula. So we have just put it in place of that, or we have replaced it. Now let us consider that probability of selecting a unit from ith sample is equals to 1 upon k, because the total number of observations are k, and like simple random sampling, probability of selecting one unit will have equal probability or equal chances of getting selected, which is 1 upon k. So now we will find the estimation. So we have to find whether the sample mean is an unbiased estimation of population mean or not. So putting it on the next page, if the sample mean, we can also write it as estimation of y bar I dot, which is nothing but estimation of 1 upon I goes 1 upon n summation j goes from 1 to k n yij, and estimation is the multiplication of probability into the formula. So estimation will be, the probability of selecting ith unit will be 1 upon k, and this will be 1 upon n into summation I goes from 1 to k summation j goes from 1 to n yij. Now this whole formula is nothing but capital Y bar. So we can say that population, that sample mean of systematic sampling is an unbiased estimator of population mean. Capital Y bar. We can say that. Now moving on to variance of sample mean. So variance of sample mean can be written as variance of y bar sy, which is equals to estimation of y bar I dot minus capital Y bar whole square. Now removing the estimation, we'll multiply it with probability. So it will be 1 upon k summation I goes from 1 to k y bar I dot minus y bar whole square. Here also we have forgotten to put the sum. Okay, we have put the summation here. This one summation after removing estimation sign. So it will be 1 upon k summation I goes from 1 to k y I bar can be written as 1 upon n summation j goes from 1 to n yij, and this also we can multiply and okay, y bar can be written as n upon n into y bar, and 1 upon n, this above n can be written as j goes from 1 to n y bar, because this n will get cancelled. So instead of y bar I am writing here it as 1 upon n summation j goes from 1 to n capital Y bar whole square. Now the next step would be 1 upon k summation I goes from 1 to k, 1 upon n, summation j goes from 1 to n, yij minus capital Y bar whole square. Taking the common outside, the next step would be variance of y bar systematic is 1 upon k, summation I goes from 1 to k into 1 upon n square when it comes out of the bracket, and summation j goes from 1 to n, yij minus capital Y bar whole square. So this will be 1 upon n square k, summation I goes from 1 to k. If we open this bracket, we are left with summation j goes from 1 to n, yij minus y bar whole square plus summation j goes from 1 to n and is not equal to L goes from 1 to n, yij minus y bar into yil minus y bar. This is the formula that we read in estimation theory or estimation model. I hope you all know where this formula came from. So now multiplying the rest others inside, we are left with 1 upon n square k, summation I goes from 1 to k, summation j goes from 1 to n, yij minus y bar whole square plus 1 upon n square k, summation I goes from 1 to k, summation j not equal to L goes from 1 to n, yij minus y bar, yil minus y bar. So this thing, we all know that this is nothing but our variance of simple random sampling without replacement with an extra k, with an extra n. Okay, so one more thing, as nk is the total population here. So here we can write it as 1 upon n capital N. Summation I goes from 1 to k and j goes from 1 to k, yij minus y bar is nothing but s square into n minus n. N minus 1. Okay, and this thing remains as it is. Summation. Okay, let us take this as q. So, and put it as equation number 1. So, for q, we know that rho is nothing but correlation coefficient. We all have learnt about what is correlation coefficient. The formula for correlation coefficient is rho is equals to estimation of yij minus y bar into yil minus y bar upon estimation of yij minus y bar whole square. This is the formula for rho. If we remove estimation, we will get summation I goes from 1 to k, summation j not equal to L goes from 1 to n, yij minus y bar, yil minus y bar upon the probability. Probability for selecting ith term is k, for selecting jth term is n, and for selecting lth term is n minus 1. And similarly, this would be summation I goes from 1 to k, summation j goes from 1 to n, yij minus y bar whole square divided by selecting it would be k. So here kn and kn gets cancelled, and this is nothing but the simple random sampling without replacement. So we can write here it is equals to n minus 1 s square. So here from here we can get summation I goes from 1 to k, summation j goes from j not equals to L goes from 1 to n, yij minus y bar into yil minus y bar is nothing but rho into n minus 1 s square into small n minus 1. This will be our formula for Q. Now we have found out what is Q. From equation 1, and 2. Let this be equation number 2. From equation 1 and 2, we can say that variance of y bar systematic is nothing but n minus 1 upon capital N into small n s square plus n minus 1 small n minus 1 s square into rho, and there was one more thing in the denominator, it is 1 upon n square by k. So we'll put it as well, n square k n k n can be written as these two are capital N and small n, so nn. Taking out the common terms outside, n minus 1 nn s square, we are left with 1 plus n minus 1 into rho. So this will be our variance of y bar sy systematic, where rho is nothing but correlation coefficient. This derivation has been asked multiple times in the PYQ, this one, and it is very important. So while solving the PYQ, you can solve it by here, and I have explained each and every step. Now, what are the effects of rho? So our formula is nothing but variance of y bar systematic is nothing but n minus 1 into s square upon n bracket 1 plus n minus 1 into rho. If rho is equals to 0, if rho is equals to 1, and if rho is equals to minus 1, then what will happen? So if rho is equals to 0, if we put here, then we will get variance of y bar systematic is nothing but n minus 1 upon n s square, which is nothing but variance of y bar simple random sampling with replacement, right? And where if rho is equals to 1, variance of y bar sy systematic is nothing but rho is 1, then it would be n minus 1 upon capital N into s square, which is nothing but sigma square or population mean. We have done two formulas for population mean, one is sigma square and one is capital S square. So this one is sigma square. And if rho is equals to minus 1, then variance of y bar systematic is nothing but n minus 1 upon n s square s square into, if it is minus 1, then it will be 2 minus n. So these will be the results. In the exam, they have asked you for first of all estimation, then variance, and then the results. What are the results? What are the effect of rho on the variance of systematic random sampling? So this was it for today's lecture. From tomorrow, we will move forward in the same topic, systematic random sampling. I hope you got all that we have done in class, and keep on doing watching the lectures regularly and doing it side by side simultaneously. That will only improve you and will encourage you for the exams, and start solving PYQs as well along with us. All the best. Thank you.